Today we're going to be looking at solving a system of linear equations algebraically by using a method called substitution. And to use substitution, one of the key parts of this method is that one of your equations must have a variable by itself. So we're going to talk about our equation over here and how we're going to make that happen. Once we get the variable by itself, then we'll actually do the substitution, hence the name of this method. We'll solve our equation, substitute our value again, find our second value for our ordered pair, and then we'll write our final solution as the ordered pair, just as we did with graphing. Since we're using algebra to solve instead of graphing, we're still going to get the same solution, just in a different method. So here's what we're going to do. The first thing it says is that one equation needs a variable by itself equal to one variable, and I don't have that. These are both in standard form. So you're going to scan your equations and see which one would maybe be the simplest to get a variable by itself, and in my case I think I'm going to go with y here. It has really just a -1 as its coefficient, so I'm going to work with that variable. So the first thing that I'm going to do to this equation is solve it for y. So we're going to take this, we're going to get y by itself, and it's going to look like this. We'll start with -y equals a -2x plus 7 by subtracting the 2x to the other side. And then we'll multiply everything by -1, so we end up with a positive 2x minus 7. So now we'll be using this equation instead of this one that we have up here. And now here comes the substitution part. So now that we know that y by itself is equal to the expression 2x minus 7, I'm going to take that 2x minus 7 that I got right here, and this is where the substitution comes in. It's going to substitute into the other equation in my system for y. So we're going to set up a new equation that is going to result in only having one variable, the x's or the y's. So we'll keep the 4x, we'll keep the 3, and then where the y was before, we'll put in our expression 2x minus 7, and then equals 4. And as you can see, what's happened here is that now, instead of having x's and y's in my equation, I have all x's. So we'll just solve this algebraically. We'll do our distributing. So we'll get 6x minus 21 equals 4. Combine your like terms. 4x plus 6x is 10x. Add your 21, and we get 25. Divide by 10 to finish up, and we get x equals 2.5, or we can leave that as 5/2. Okay, now that we know that x is 2.5, we will take our value of 2.5, just like it says up here, substitute the value we just found into either of the two previous equations. Well, to be honest, in substitution, the easiest equation to substitute this back into is our y equals 2x minus 7. So what we'll do is we will substitute that back in. Y equals 2 times 2.5 minus 7, and we will calculate that out to be 5 minus 7 is -2. So I will end up with a solution in my ordered pair form of 2.5 comma -2. This would be the point where these would cross. And just like we talked about previously when solving by graphing, one of the benefits of solving algebraically is when you have solutions that do not come out at whole number or integer type of points, it's a lot easier to know exactly where those points will intersect when you're using algebra instead of just graphing as your method of solving the system.